Hello everyone, welcome back to the channel. I hope you guys are doing really well. So let's see today's daily challenge on Leetcode and we will try to solve it together. So let's see the problem statement and try to understand what it does and what it is asking us to find. Okay, so unique length 3 palindromic subsequences given a string s, return the number of unique palindromes of length 3 that are a subsequence of s. Okay, so you need to find all the subsequences of a string which is a palindrome and is of length 3 and they are unique to each other. Okay, if there is repetition you should not count those repetitions. Okay, so yeah, I hope you already know what does a palindrome and a subsequence means, right? I hope that at least that much I won't have to explain you here. So yeah, if you try to see this example, you can get three palindromic subsequences: ABA, AAA and ACA. Okay, and all of these are uh, are palindromes and they are all unique. Okay, so you get three unique count. You see you did not get any palindrome here, and if you see for this case you get four palindromes, right? BBB you can get for the subsequence, and BCB also you can get, BAB you can get, ABA also you can get. Okay, I hope you are not confusing a substring with a subsequence. Okay, so yeah, that's what we need to select subsequences. And yeah, so if you try to form an example on your own, you will easily understand the pattern and you will easily understand what you need to do. Okay, so let's say you have something like A, C, X, Y, C, D, F, A, something like that, and let's say you have B over here. Okay, so you see how can you form a palindrome of length 3? So there are two possibilities. Let's say you have two characters X and Y. There is a possibility that palindrome is forming when all the characters are repeating, XXX or YYY. This is a palindrome. And otherwise it could form only when the outer two characters are same and the inner one is different. Okay, so I hope you do understand how a palindrome will look like. And yeah, how do you get this kind of palindrome? You see, if you are selecting subsequence, so for sure what you can see for in the pattern which I showed you, XXX or XYX, what do you observe in this pattern? You observe that the first and last characters are same no matter what. No matter what type of length 3 palindrome are we talking about, the last and first characters are same. Okay, so yeah, for a subsequence I will first look for that. So you see there is this A and this A, so they can form subsequent, they can form palindromes. So can you tell me what are the palindromes which can happen? So in between these two A, how many characters are there? You can see ACA, you can see AXA, you can see AYA, you can again see an ACA, but it is same as this ACA, so we do not need to count that, right? And you also see an ADA, you also see an AFA. Okay, so with A only you get 5 palindromes. Okay, all of these are palindromes if you notice, right? And so what do you need to do basically between, so you need to measure between two same characters, between two same characters, how many unique character exists, how many unique characters exist, unique characters exist. You see between these two A's, how many unique characters is existing? 1, 2, 3. This is not unique. 1, 4 and 5. So you see 5 unique characters. That's why you get 5 palindromes. Okay, now similarly you can see if you consider this same example, B, A, C, X, Y, C, D, F, A. Here are two C's also, right? And you can also get the palindrome C, X, C and C, Y, C, right? So for these two palindromes you get two of them, because between these two same numbers, between two same characters, there are two unique characters. Okay, so I hope and you know that no matter how long the string is, no matter how long this string is, the characters possible are only 26, right? So you can technically do a brute force approach. How you can do that brute force? uh, what you do is that you iterate through all the 26 characters and you see that, let's say now you are iterating through A. Okay, so you just take the first occurrence of A and the last occurrence of A and you store those indices. Let's say these indices are I and J. Okay, then you can iterate. Let's say in this string A exists here, the first A exists here and the last A exists here. Now between these two you can iterate from I plus 1 to J. right? You can iterate from I plus 1 to j between these two. So what can you do for that? You can just iterate for that and just check how many unique characters are there in between them. And you see O of 1 n time will take when you are iterating from I to j, O of n time O of n plus another n time will take to form this I and j, plus you see multiply by 26 times you need to do this. So O of whole thing is in of order of O of n, which will work definitely. Okay, so I hope you do understand what I'm trying to say. And yeah, uh, first thing which you can do, instead of iterating through all the 26 characters, you can keep a set of character. Okay, set or unordered set, whichever you take. You can keep a set of characters, and for once you can just iterate through this, let's say the string, and just add the elements into this a set, okay, which will give you the unique characters only. So you do not need to even do this 26. Then it will be, I mean, even much more optimal, because every time all the characters A to Z may not be present. Whichever character is only present, you are only iterating through that. Okay, so you can do that optimization also. So let us see how can we do it. I hope it will be very simple. Let's see. I can choose to take an unordered set, because it would give me an amortized O of 1 time complexity. And this set, what I can do is that I can iterate through all characters in this S and do set dot insert S. Okay, so once I do this, set dot insert C. Okay, so once I do this, I get all the unique characters which are present in the string. Okay, so for I can go through these characters, right? For auto ch in this particular set, I want to see that what is the first occurrence and the last occurrence of this. Okay, so let's call it the left as the L as the first occurrence, left, and right R as the rightmost occurrence, right? And how do we actually do those? Let's see. Let's call it -1 -1. Okay, we will just have those, and I can just iterate through the whole string once. Okay, so how can I iterate? I can again use this simple auto, let's say for auto x in S. What do you see? Yeah, we need the index numbers, right? These are nothing but uh, index numbers of first and last occurrence. Okay, so definitely this auto iteration won't work. I have to use int I. Okay, so yeah, int I equals to 0, I less than n, I plus plus. What I can do that if this s of I is equal to ch, what you will do for the first occurrence only, if L is equal to -1, it means that it is the first occurrence. L has not yet been updated. Then what you can do is that you can update it, right? You can update L as I. Okay, you can update L as I, and irrespective of anything, in every iteration, you just keep updating R also, right? So if you keep updating R, control X, okay. If the character matches, you just keep updating R for every iteration, irrespective of whether R is -1 or not. This will help you to get the last element only. Okay, the last element in R. Okay, so now L and R you are having with you right now. All you can do is perform an iteration. Okay, so how can you perform that iteration? You can, let's say, have character C starting from let's say an index, right? So what do we call the index? I can call this index starting from L and L plus 1, right? We need the number of unique characters in between. So now what we are doing is finding number of unique characters in between. So this less than n and not n, R, and index plus plus. Okay, so what do you want to see is that, and find the number of unique characters. Okay, so for simplicity, what do I do is that I create another unordered set, okay, of characters, and I call that let's say between characters, okay. Between. So what can I do? I can just simply insert this between dot insert. So in between I'm traveling and inserting all of those characters s of index, all of these s of index into this between, and yeah, so I can just have a global variable answer and do an answer plus equals to uh, between dot size. I hope that is simple, and return answer, right? So yeah, we have this, and we definitely we need to initialize our answer to 0 also. So we do that here. So yeah, I hope it will work just fine. You can try to run it and check if it works, or we need to debug it. You see, we get the accepted thing. If you try to submit it, I hope it will still work fine without any error. Let's see. Yeah, it does work fine, and yeah, you get an okayish runtime complexity. It varies a lot. We are using, I hope you do understand that we are using a simple O of n runtime complexity here, and yeah, it cannot go better than this. You can think of some methods of optimization if possible by pre-computation. You can try those, but I hope you did understand what how we need to solve this problem. I guess it was an easy kind of problem, only easy medium kind of problem. This should not be any difficulty. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.